Bismillahirrahmanirrahim. Next topic according to your syllabus is measure of dispersion or variation. In measure of dispersion, we measure the variation of the data. There are four types of measure of dispersion. Number first, range. Number second, quartile deviation. Third, mean deviation. Fourth is the standard deviation. And the formula of the range is equal to, you know that maximum value minus minimum value. You have used this formula, this range, in frequency distribution table. With the help of range, we find the range of the data, how disperse the data from minimum to maximum value. And number second and number third are not included in your syllabus because quartile deviation, quarter means 1/4. In quartile, we divide the data into 4 equal parts. And you know that in median, we divide the data into 2 equal parts, same as in quartiles, we divide the data into 4 equal parts. But quartiles are not included in your syllabus. In quartile deviation, we use the quartiles. So this quartile deviation is also not included in your syllabus. Number third, mean deviation. In mean deviation, we find or measure the variation of the data, absolute value of the data from mean. Absolute value of the data from mean. Absolute values means if the result of the midpoint and mean is negative, we convert into positive. We ignore the negative sign. And this is also the drawback of the mean deviation, because we convert the negative or positive both value into positive values. But this is also not included in your syllabus. Number fourth method is the standard deviation. Standard deviation is free from all the demerits. With the help of standard deviation, you can find the variation of data from mean. Either the variation or deviation from mean is negative or positive. We use the standard deviation. Negative value same as negative value, positive same as positive value. So standard deviation is free from all the demerits. This is the definition of standard deviation. The standard deviation measures the variation of the data from mean. Mathematically, it is defined as, this is the formula, mathematical formula. It is defined as, it is the square root. It is the square root of the sum of the sum. This summation sign means sum. Sum of the square deviation. Sum of square deviation. This is the square of the deviation. Deviation from value minus mean. Deviation means difference. Sum of the square deviation from mean. It is given by, there are two formulas. Both are same, but for ungrouped data, standard deviation represented by S is equal to under root xi minus x bar whole square divided by n. Same as the mean, you know that in mean of the ungrouped data, xi represent the given value, x bar is the mean, n is the number of observation. So if you subtract individual value from mean of the data and then take square of this deviation and then sum of all values, then divided by number of observation, you will obtain this standard deviation after square root. If you take square of this term, root sign will be cancelled, is called variance. This is the variance. Sometime in some method we use the variance like f test, etc. And standard deviation, both are approximately same. You should take square of this term, will be variance. Formula is same. we use according to the requirement, standard deviation or variance. If you have variance, you can calculate, find the standard deviation. If you have the standard deviation by squaring both sides, you will obtain the variance, where xi is the given value, this value xi, x bar is the mean, and n is the total number of observations. So this is the formula of the ungrouped data. You know that if the number of observations are small, not value, observation 5, 6, 7, 8, we use the formula of the ungrouped data. If the number of observations are large, first we convert the data into groups, then we use the group data. So now first we will solve the example of the ungrouped data. This is the example. Calculate the standard deviation of this data. There are 6 observations. Ungrouped data. First we will calculate the mean, add all values, divide by 6, 50, and then subtract xi. Xi is the value 46, minus mean square. Summation sign means plus sign. Summation sign means xi value minus mean, then square, then next value for summation sign. Same as second value 69 minus mean whole square plus third value 4, 5th and 6th. First calculate the square of this term. Difference is 4 whole square. Difference is 69 minus 50, then whole square, 32 minus 50 whole square, and so on. Add all values, divide by 6, and then take square root. You will obtain 13.31, and the conclusion will be the standard deviation of given data is 13.31. So first we calculate and then subtract all values one by one, and then calculate the standard deviation. Now this is the formula of the group data. Same as the previous formula, if we write here fi, and instead of n, summation fi. You know that the n is the total number of observations, summation fi is also the total number of observations or frequencies. Same as the mean, you will multiply the corresponding frequencies for numerator term. So fi into same term xi minus x bar whole square divided by summation fi. But what is the difference between group and ungrouped data? In group data, xi is the midpoint. Ungrouped, xi is the value. First we calculate the midpoint minus mean whole square, difference of this, and then square, then multiply by corresponding frequency. Same as the mean, multiply by the corresponding frequency, and then calculate the sum of all values divided by total number of observations. Same as ungrouped data, if you take square of this term, you will obtain the variance. In this, xi is the midpoint, x bar is the mean, fi is the corresponding class frequency, same as the mean. Fi into xi minus x bar whole square is the sum of the product of the corresponding class frequencies. Okay, total term is from this point to this point, sum of the product of the corresponding class frequencies, and xi minus x bar whole square and summation fi. And summation fi is the total number of observations. Okay, this sentence start from this point to this point. Fi xi minus x bar whole square is the sum of the product of the corresponding frequencies. This is the corresponding frequency, and this is the term corresponding frequencies and xi minus x bar whole square. First we will multiply both term and then sum of this. So fi xi minus x bar whole square is the sum of the product of the corresponding frequency and xi minus x bar whole square, and summation fi is the only total number of observations. Okay, Now we will apply this formula for the first data of the air pollution of the 50 observation. You have already used for mean, median and mode. So this is the given data. Question is calculate standard deviation of the first data. Example number 1. This is the mean of the first data. You have already calculated the mean of the first data. Mean is 38.1. You can check in your previous videos of the mean, median and mode. You have already calculated the mean of the first data. So this is the mean of the first data. You have already calculated. If you have the data, first we will calculate the mean, but you have already calculated the mean. And this is the frequency distribution table. We will draw the column according to the requirement due to the shortage of the space. This is the class interval of the first data. This is the frequency. We will use the frequency in this and midpoint in standard deviation. Because you know that we required this term fi into xi minus x bar whole square. Xi is the midpoint, x bar is the mean 38.1 fixed for all value, then take square, then multiply by corresponding frequency. So 16.5 first midpoint minus 38.1 mean, then take square of this, first take square of this term, after their difference then multiply by 4. If you first multiply by 4 then square will be wrong. Same as second midpoint 26.5 minus 38.1, then square multiply by 19 frequency. Same as for third group 4, 5, 6 and then add all values. So this value is the sum of the product of the xi minus x bar whole square and corresponding frequencies. And substitute this value in formula. This is the formula, this is the numerator term divided by 50 and simplify, we will obtain the standard deviation. So you can observe from this, substitute here 11872 divided by 50, you will obtain 237.44, the square root is 15.41. The conclusion will be the standard deviation same as the mean, median, mode. Write the method here. The standard deviation of air pollution of 50 large cities is 15.41. Okay, now for homework, this is the fourth homework. Calculate the standard deviation of second data, or example number 2. Next time we will start new topic. Allah Hafiz.